You know there's a silent pandemic happening right now? It's called antimicrobial resistance. And what it means is that the drugs we count on, well, they're starting to fail. These dangerous pathogens are evolving way faster than we can respond. But what if we could actually get ahead in this fight? Well, there is a way, and it all starts with getting the right information, and getting it fast. See, for a patient with a really severe infection, every single hour matters. The difference between giving them the right antibiotic versus the wrong one can literally be the difference between recovery and tragedy. So the heart of this crisis, it isn't just about developing new medicines. It's about information, and specifically how fast we can get that critical information.
And this is the question that keeps us up at night. It's so frustrating. In an age where we have information at our fingertips, why are doctors still forced to make an educated guess while some slow, outdated diagnostic test just runs its course? It just doesn't make sense.
So what's causing this dangerous delay? Honestly, it's a technique that's over a century old. We're still relying on the culture method, basically trying to grow bacteria in a petri dish. It's like trying to fight a 21st century war with 20th century weapons. We are, for all intents and purposes, fighting blindfolded.
And look, these aren't just minor little issues. They're critical failures. The time it takes, that means patients get sicker while we wait. The limited sensitivity, that means we might miss the real threat. And the method has all these built-in biases, so we often get the wrong answer entirely. It's a system whose limitations have direct and sometimes tragic consequences for real people. So the solution has to be a whole new way of thinking. We're proposing an autonomous system that goes from sequencing a pathogen's DNA right to a decision, something that delivers the right answers right away. It's time to move from the slow, manual work of a petri dish to the incredible, rapid insight of the genetic code. And here's exactly how our workflow gets that speed and precision. We take a sample and we pull out all the microbial DNA. Then we prep that DNA into what's called a library for analysis. And this is the cool part. We use cutting-edge nanopore technology to read the genetic code in real time. Finally, our automated software takes all that raw data and translates it into a clear, actionable diagnosis. And the result is just brilliant. This is the power of what we get. We don't just tell a doctor what the pathogen is, we show them its entire genetic blueprint for resistance. This lets a clinician see exactly which antibiotics are going to work and which ones are going to fail. It enables truly precise, targeted treatment right from the very beginning. Really, it all boils down to this simple, powerful process. You take a sample, you sequence the genetic material inside it, and you get a real, actionable solution. Sample, sequence, solve. It's that straightforward. We're turning days of guesswork into just hours of certainty. And I want to be clear, this is not just an idea on a whiteboard. We have already demonstrated its power out in the real world. We've taken it from just a proof of concept to a proven, validated technology. To track our progress, we use something called the Technology Readiness Level, or TRL scale. And our system, it's already at TRL 5. Now what that means is the technology has been tested and validated in a relevant, real-world environment. It actually works outside of a pristine lab. This isn't a theory anymore. It's a functioning system with proven results. So what did that TRL 5 validation look like? Well, we took on a really tough challenge, monitoring complex healthcare waste. And in those tests, we successfully identified dangerous pathogens, things like Proteus mirabilis, and we pinpointed the specific genes, like BLATM1, that make them so resistant to common antibiotics. And here's the really incredible part. Our platform detected these threats even after that waste had gone through standard microwave sterilization. I mean, think about that. It proves just how incredibly sensitive our system is, and it shows its massive value for monitoring public health risks that other methods would completely, totally miss. So, where are we going next? As I said, we're at TRL 5. We have a validated technology. Our goal now is to reach TRL 7, and that is the critical leap. This is what takes our technology from being a proven component to being right there at the patient's bedside. It means developing a complete system prototype that can be demonstrated in an actual hospital, making it ready for real-world clinical impact. And to make that massive jump from TRL 5 to TRL 7, we are seeking your support. This funding is the catalyst we need. It's what will allow us to integrate and automate our system into a robust, deployable prototype. A prototype that doesn't just generate data, but one that will actually guide life-saving clinical decisions, giving doctors, and all of us, a powerful new weapon in this crucial fight.